Hello, today we are going to cover 2.7, graph absolute value functions. So, this first example is pretty simple because all we have is a single absolute value. So if you plug in the absolute value of 2, you get a 2 for y. You plug in the absolute value of 1, that's a 1. The absolute value of 0 is 0. The absolute value of negative 1 would be positive 1 because we're talking the distance away from 0, and distance is always positive. And the absolute value of negative 2 is 2. So with these, we'll just go ahead and plot these points. So 2, 2, 1, 1, 0, 0. And then negative 1, 1, negative 2, 2. You can go ahead and draw in your graph then. And our absolute values look like a sort of V. Now there's a couple things here. Where we have our vertex, it's either the lowest or highest point. We can draw a vertical line through that, and this is called our axis of symmetry. In this case, our axis of symmetry is x equals 0. That is our axis of symmetry. So we're going to write the definition of axis of symmetry down here. So we have symmetric about our axis of symmetry. This is a vertical line through the vertex. So when I say it's symmetric about it, that just means this point is 1 away from the axis of symmetry and the other point on the other side is 1 away. These are 2 away on each side. So really we can draw one line and then just reflect it across. Oops, too much. Okay, so our equation to graph absolute value functions in a specific form is y equals a absolute value of x minus h plus k, and we'll learn what a, h, and k do to our function. So we have a vertex at the opposite of h, comma k. So we can find our vertex just based on what the equation looks like. Okay, and then we'll label these guys. A is our slope of our line, kinda, and h and k we will see down here. So I'm going to scroll down, I'm going to write out some important pieces here, and then we'll try our examples. So our a value, we saw it was our slope, kind of. This is a stretch or compression. Stretch or compress is a. So if a is bigger than 1, you can also write it like this. This makes a narrower graph. This is called a stretch. Your math Excel will ask you about that. So to make it narrower, more in like that. If a is between 0 and 1, so it's a fraction, this makes a wider graph. And this is called a compression. It's kind of counterintuitive because the compression makes it wider, the stretch makes it narrower. That's the first thing A does for us. There's a second thing. I'm going to shrink this down. The next thing A does for us is a reflection. So this is also A. If our A value is positive, think of a happy smile. Our absolute value opens up. If our A is negative, it's sad, so our absolute value opens down. So those are the things our A value tells us. We also have H and K, which we have not talked about yet. H and K are our translations. So this makes it move side to side. So H will move our vertex left or right, and K will move our vertex up and down. Now, a word of caution here for the H value. Be careful with our H values. If we have a negative H, this moves our vertex right. And if we have a positive H, this moves our vertex left. That seems opposite. Usually if something moves right, it's positive, and if it's negative, it moves left. So keep that in mind when graphing these. They move opposite of what you would think. So we have stretch compressed of A, we have reflection of A, and we have translations. Okay? Now let's use these to graph 3 examples. So we first need to find our vertex. Now, I will tell you, you could use an X, Y, T table, pick out random values for X, plug them in, solve for Y, and then plot it. You could do that. But if you know how a graph moves, we're going to do this like 5 times. If you know how a graph moves, you'll be able to move it without even plugging in and doing any math. So, for our vertex, we need these 2 numbers. Our vertex is the opposite of H, which is the number within our absolute value. So if we have positive 4, it becomes negative 4, comma, K. And K is the number that's added or subtracted on the outside. So minus 2. And K's value sign stays the same. So our vertex is at negative 4, comma, negative 2. Let's plot it. So that is our vertex. Now we know we have an axis of symmetry here. We can state our axis of symmetry. Not all problems will ask you to do that, but you might as well know how to do it. It'll be at x equals whatever our x value of our vertex is. So negative 4. Then we need to look at our slope. So if there is nothing multiplied by the absolute values, we know that the slope is 1. So our A is equal to 1. And since it's a kind of slope, you can say 1 over 1. So from our vertex, you'll rise 1, run 1, rise 1, run 1. And then you can graph it. Now an absolute value always makes a sort of V. So now we can reflect this across. We're 1 away from the axis of symmetry, so our new point is right here. We can do that as well. We're 2 away, so our new point is here. Or you can think of it being the negative slope, the opposite slope of what we had originally. So then we graph negative 1, 1. And that is our graph with our vertex and our kind of slope. Okay, let's try another one. In this case, we have another graph, but we have no h or k values. When there's nothing, no number inside with this, that means the h value is 0. If there's no number added or subtracted outside, that means the k value is 0. So our vertex here is at 0, 0. And our kind of slope, our a value, is negative 3. And you'll put that over 1. We know our axis of symmetry goes through our point, so it is x equals 0. So we can graph from our point using our slope. Notice the a value is negative. So we'll go down 3 over 1. It has to open downwards because it's a sad graph. We are going ahead and stretching this graph. You can either reflect it across or do a positive 3 over 1 slope to graph the other half of our absolute value equation, and that is our graph. Lastly, we put all things together. We have a kind of slope and we have a new vertex. So our h value and our k value, remember the h value is opposite of h, so negative 1 becomes positive 1. And our k value stays the same, so this is our vertex. Go ahead and plot it, 1, 3, goes right there. And then our slope here is negative 2, so the slope is negative 2 over 1. Notice this one will also open down, so we go down 2 over 1, negative slope. We have our axis of symmetry 2, that'd probably be a good thing to draw in. This axis of symmetry is x equals 1. And then do a positive 2 over 1 slope to get the other side, or simply reflect the points across. Draw in our lines, and we are good to go. Alrighty, that's all for today. Have a great afternoon.